Hi. Okay, so for this video I decided to do something a little bit different, and I wanted to show a little bit of an interesting element of functional programming. So basically this is a kind of a serializer deserializer. I am inventing a new notation to serialize Clojure objects. For example, a nile will be serialized just as n, a 20 will be like m, 20m, and so on and so forth. And so, for example, things like keyword would be like the size of the keyword. So in this case I have 7 elements, so it's k7k, and then what the text. So for example, if I have a keyword followed by a number, I will have like the k, the number of chars, and I know that I can feed this number of chars up to the moment when I got the end of the keyword. So I can basically say, okay, now I have, I don't know, numbers. Everything is right, everything is well, but there's a problem. That is, I am doing that because I want to serialize on a network. And networks, I will receive the data not in a single batch. I will receive chunks of the data, meaning that basically I can receive big numbers, big vectors, and I don't want to basically have to wait until I receive everything so I can parse everything, because I have to actually follow the string up to the point when I say, okay, I cannot parse this yet, so I get to backtrack everything and start it again, and that is basically slow, and I am consuming a lot of processing power to do something that I am not going to work. So I decided to do parser that you can feed string to it, and basically you get a result. So for example, if I feed n, it will get the result as a nile, and the rest, basically the rest of the string, is nothing. If I, for example, serialize nr, for example, I get the rest is the r. That's the extra chars that I have. This will not be useful for these single parsers, but will be useful for future parsers. And I have this weird situation. For example, here I am experimenting with the m20m. So now I have m2, and it cannot serialize this, and exactly how I am going to work with this. Okay, so usually when you have a function, object-oriented or any other kind of language, you have some kind of state. So the state would say something like, okay, I have feed like m2, and it's like pending, and then when I feed like something else, I say, okay, I have m20, I'm still pending, and then basically m20m, I get the result of success. And I keep some internal state on this to basically say, okay, I have a 2 here, so like for example, yeah, I have feed m2, so I have a 2 here, and then I have m20, so I have a 20 here, and now I have the m, I can basically clear the state and return something. This works really well, but there's a problem. When you have deep things, like for example a vector that's basically a collection of elements, then you have to get to the point where one parser needs to know the existence of the other. You cannot escape that too much, and it's harder to debug, but I decided to do something different. I decided to do some like functional parsing, and here I am going to show exactly how is this process. Some people might say that's similar to continuations. That's true. It's not exactly a continuation, but something similar. So here is what I am going to do. I am going to deserialize something, and that will return a function. So I am basically doing a do to, so I can check that this is indeed a function, and I return to deserialize the same function. And then deserialize gets binded to a variable, and so I can just call this deserialize again, and again up to the point that it get me a result. And in this case, it will not return a function anymore, it will return the result. Okay, so how do I implement this? Well, here is the number decoder, and it's actually quite simple. So the idea is that number decoder is something that I get. I will try to find a string, and where the string have numbers and finally an M as the ending. And if I did not find the M, if I do find the M, I basically do a parse int with the value that I have. And if I do have the M, if I don't have the M, sorry, I return the number decoder itself, an anonymous function with the number decoder, the string to feed, and this so far is how much I parsed it so far. So I get how much I parsed it so far with the string that I received in this moment. So I'm going to do a println based debugging here because it will be easier to see. So this is the string that I am receiving, and this is the how much I parsed, and I am going to run this. Let me just do the same thing here. So you can see that I received a 2, how much I parsed nothing, then I received a 0, how much I parsed is 2, and I received a, so I already had parsed 2, now I'm gonna concatenate a 0, and now I received an M on how much I parsed, it's actually 20, and that's the end of my story. Okay, everything works really well, so let's now implement this fragment here. It's basically, let me just remove this debug information. Okay, so as you can see, here's the error. I do not have a matching clause for V. V is a vector. How it works with vectors for me? I basically say that I have a vector, and then I start to parse every inner element up to the point when I end the vector. Differently from these other elements, the vector starts with V and ends with E. And the reason is I can have vectors inside of vectors, and if I had this with a V, I would not know if this is to end the current vector or to start a new vector. So that's why there's an E as an end of a terminator. Okay, so here's how I decided to check this. I will first feed a V, so it's not complete, it's the start of a vector, and now I want to deserialize an N. N is nil. And why is that? It's because it's the easiest to deserialize, so I do not have to keep track of like V1, M1M or something else. So yeah, this will be the first nil on the vector, this will be the second and third nil of the vector, and when I deserialize, I want a result that's a vector with 3 nil elements. And it's important that each of this step actually generates something for the vector, meaning that I cannot simply ignore if I do not get the E and parse everything at the end, because otherwise I will be like, it will be wasteful. So that's the idea. So let's implement this. Basically, I'm going to add a new clause here, let's say vector, and this will be a vector decoder. And what I want in my vector decoder is something like, I have to get the current string. The current string starts with like V, and I already predefined something here that's a rest. It's basically the rest of the string, the excluding the first element. So I am just going to parse the rest, considering that v is already the first element. Oh, it's already the start of the vector. I do not need to feed this on the parser. And I want to do something else here, but let's start with like the vector, an empty vector. So let's define a vector decoder. The same as previously, I have a string and I have a so far. It's basically how much I parsed so far. Okay, so the first thing that I want to do, I want to get how much I parsed with the string. So I want to get the result of deserialize of this string. Okay, this might work. Let's see if it does. Okay, so here's the first problem of doing that. Let's suppose, in this case, probably things will work fine. But let's suppose that I do not have a specific case like this. But, well, baby steps, like test-driven development. Let's just do baby steps. So let's print the result and see what happened here. Okay, so the result is deserialize. And why is that? It's because the first vector decoder, it will be receiving a string. And what is this string? It's an empty string, as you can see. Because basically, here's the first argument that I passed, a v. I strip up the v and I get something that basically does not exist. So I cannot parse this. So the first argument, the first condition that I am going to do is, if it's a function, if the result is a function, then it means that I cannot parse this yet. I am going to ask for the vector decoder to basically parse the next thing that it will be given. I want the same vector because I can't parse anything yet, and that's where things get weird, because I cannot do this. I cannot basically deserialize the stuff because I already have some result, the result of an older parsing. I need to somehow retrofit this into the vector decoder. Otherwise, for example, in this situation, when I get a number deserializer, I will not be able to keep parsing the number up to the point when I get a result. So I need a new argument here, that is the previous parse result, something like this. Okay, but I need to feed this here somehow. So the previous parser result, it will be basically deserialize. And instead of actually deserializing things like willy-nilly, I am going to run the previous parse result. This will fail, we will see in a minute, but it is what it is. Let's just say like parsing string, and the result will be something like this. Okay, so here is the first argument, and let me just move this to the top so we can see the error when it happens. Oh, I cannot move this to the top. So, okay, let's just migrate to different things. Okay, so I'm parsing the string. It's nothing. Now I am parsing the string n, and the result is oh, sorry, vector decoder needs to get the previous parse result, otherwise this will be null. Okay, now we're getting somewhere. Okay, so parsing string, nothing, so I get back a function. Parsing string null, I get back a result, a real result, and now I get something weird, that I was expecting a function and I actually got back null. And why did I get back null? It's simple, simple really, because here I did not get a function as a result. I got back a real value. So it's not a function, the result. It's actually like something real. It's something that I actually can treat. So in this case, usually we do else for cont. I prefer to do something like real values to explain what I am doing. Again, I get back a result and a rest, and I am going to let some keys here, result and rest, and get the result, so from the previous result. And here's what I'm going to do. I am going to call back vector decoder. As we are in tail position, I can call recur, so I don't like blow up the stack. So this is a tail recursive element, and I am going to parse the rest. That's basically what's missing from the parsing. The previous parse result, I don't have it anymore because I am not a function right now. I am something that I need to deserialize. So it will be deserialized again because I am parsing a new value right now. And so far it's actually the conjunction, or basically a new element, of the vector that I have so far with the result that I got here. Okay, so this now gets us a different error. And why is that? It's because first, there is no matching clause E. And where is this matching clause did not exist? It's on this case. Because right now I am asking to parse a string that's basically E. That's the end terminator. And it's not what I want actually. I want to treat this E inside the vector decoder. So there's an easy way to do that. Basically to move the result to somewhere else and basically reuse it if it's not like a terminal. But I am going to do this. I am going to use delay. If you're not familiar with delay is basically a way for Clojure to not evaluate this expression and basically keeps it lazy. So now every time I use result, like for example here, I have to dereference it, and I have to dereference it, and I have to dereference it. And that's fine, basically. That's fine. That's exactly what I want. I want for my delay to just wait to parse, because I am going to add a new condition here. I am going to add the condition of like string first equals E. That means I got a terminator for this vector. So if I got a terminator for this vector, then what I need to do is that I need to do the result, return a result. That is exactly the so far, basically how much I parsed it so far, and the rest is the string with one element less. And wait, oh yeah, I need to, this is the condition and this is the result. My parentheses were unbalanced. And what happened here? Oh yeah, I cannot dereference here. I need to, if I dereference here, I don't do the condition. So now I have something that for some reason I don't have the result here. So the result is nio, 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 and oh wait, so far not an empty vector. Okay, so now I'm parsing the string nothing, and I got back n, nothing, then n, then nothing, then two n's, then nothing again, and finally the terminator, and everything is running. Okay, so let's dive deeper into what this do with like a step-by-step tutorial. So first things first, let me just define all these variables here. That's an amazing thing that we can do in Clojure. We can debug like this. Okay, so farm, previous back, and the string. And I am going to define a result here too. Okay, so first things first, what happens when I do this? And what happens is, I get a string that's empty. A previous parse result is this serialize function, and so far I have an empty vector. And my result is the same deserialize that I had here. So now when I feed this some nio thing, what will happen is that I am parsing again an empty string. The previous parse result is still the serialize, but so far I got a nio. And why I have an empty string and why I have like the deserializer? So to solve this question, to answer this question, I am going to do something even more interesting. I am going to print something like parsing and then the string that I am parsing. I'm going to do the prn because it will normalize the string. Okay, so I am parsing an empty string because the v is elided from my function. And now I am going to parse a d. And as you can see, I run that code 2 times. One to parse the n, which will return me nio, and the second one to parse an empty string. And that's why string here is an empty string, and why the previous parse result is again the serialize function, because I had parsed the string. So now let's do something different. Let's define a third deserializer, but let's use a number. Okay, so I am parsing m right now, and as you can see, I'm still on the deserialize function, and I am going to parse, oh wait, sorry. I have to call d2. Okay, so now I'm parsing the thing, and what will happen with d form if I send an n? The previous parse result, it's not the same deserialize function. And what is this function? What exactly is this? And that's where things get interesting. It's the number decoder inner function here. So as soon as I end this with an M, I will probably have so far here the number 1. That's exactly what I wanted, because I basically delegated to the other element. And finally, if I call d5 with the terminator for my vector, I will get back nil and 1. That's exactly the flow here. I declare the vector, put a nil here, put an m, put a 1, put a m to basically close the number, and finally I got back my result. So it's an interesting way of how to think about functional parsing and functional programming in general. So I still have state, but as you can see, I am not mutating anything. I am basically returning functions that will continue parsing in the future, which is kind of weird because these functions here are points in time that I can change. And it sounds weird, maybe it is, but let's suppose that I want to continue parsing after the D2. So I have a nil, I want another nil, and I want a number. The number will be 22. I finish the number and finish the vector. And that got me nil, nil, 22, which is wonderful because I did not implement any code to backtrack what I wanted. I basically continued my parsing from this point in time because I already, it's everything is immutable basically. This D2 is just a continuation of the parser in that state that it was. So let's suppose, for example, D3, I already started a number. So let's start another D3, but this time let's just put 26 here. And as you can see, I will get the N, I already started the M, so I'm going to just get 26, and the result will be a nil and 26 here. And here it is. Finally, let's do starting D4. And that's interesting because I am now already feed 1 to the element, meaning that this will be 1, 2, 6 in the last position. And as you can see, it is 1, 2, 6 in the last position, which is kind of neat, honestly. And finally, I could do whatever I want. Like, for example, I can continue on D5, but basically include another nil here. Oh, wait. I forgot that another nil and another 1, or another nil, another 7. And as you can see, it continues from where we started. So it's a stateful parser in some way, because you actually are keeping state, but at the same time, it's a stateless parser. It's fast, it works, but I do not keep state, like I do not keep mutation, I keep state in an interesting way. I hope you like this technique, and see you next video.